The concepts of REST are very closely related to HTTP. HTTP, as you probably know, is everywhere on the internet. Every time you load a web page, you make an HTTP request and you get HTML content in the response. REST is inspired by a lot of the concepts of HTTP. Roy Fielding, the one who coined the term REST, is one of the principal authors of the HTTP specification. So it's no surprise that a lot of the ideas behind REST make good use of the ideas and concepts behind HTTP. So to understand REST, you really need to have some basic understanding of HTTP itself. Notice that I said HTTP specification that Roy Fielding was one of the principal authors of. Yes, specification means rules. So what defines HTTP is clearly laid out in the specification. So unlike REST, there's no vagueness about it. So let's understand a little bit of HTTP. HTTP stands for Hypertext Transfer Protocol. Like we've already seen, you can think of a protocol as a language or a mechanism for communication. So HTTP is a way to exchange and communicate information online. The stuff that you exchange and transfer in HTTP is called hypertext, hence the name Hypertext Transfer Protocol. Hypertext is a structured form of text that has one interesting property. It contains logical links to other text. These links are called hyperlinks. Okay, so hypertext is text which contains links to other text, and the links are called hyperlinks. I'm sure you know what hyperlinks are. It's very common on the internet. A common and a popular way to write hypertext is in a language called Hypertext Markup Language, or HTML, which is again something you already know. I'll not go into the details of HTTP entirely because that's beyond the scope of this course, but let's switch to REST and we'll look at some of the HTTP concepts that have inspired REST and how these concepts apply to RESTful APIs and services. The first concept is of resource locations. So just like web pages, REST APIs have URLs and addresses too. That way they're similar to websites. And like we talked about in the previous tutorial, one major difference is since these web APIs are not meant to be read by humans, the response usually contains just the core data. For example, you need to look up a weather for a place on a weather website. You basically get a response with HTML showing the weather in a readable format. The HTML return might have some other HTML elements, CSS for styling, the site banner, some ads on the side, and so on. This is because the response is meant to be read by a human being. But a REST API for a weather service probably has just the weather data in XML or JSON. Now, since APIs have addresses, an API designer or a web service developer needs to decide what those addresses should be. The practice in the RESTful APIs is to have resource-based addresses. In the case of a weather website, the URI to look up a zip code, say 12345, could be something like this: weatherapp.com/weatherlookup.do could be a starts action, question mark, which is a query parameter, zip code equals 12345. This is a perfectly valid URI, and it's common to see addresses like this too. But this address is not resource-based. I would say this is more action-based. It tells you that there is something called weatherlookup.do that takes the zip code as a parameter and then does something, right? It does weather lookup. Resource-based addresses, on the other hand, indicate just the resource, and they are independent of the server-side implementation. For instance, a RESTful API for a weather could have the address /weatherapp, which is the same, /zip code /12345. It's almost as if you're not making the server do anything, but rather just looking up something that already exists. So the weather for zip code 56789 could be weather app / zip code / 56789. Right? It's as if that thing's already there and you're just looking it up rather than doing any processing. The server might be doing any processing, but the URI doesn't show that. It's like you're doing a lookup of something. And you could extend this URI. So a weather forecast for a country could be designed to be at /weather app / countries / the country name. In a later tutorial, we will discuss about how to go about designing these addresses when when writing RESTful APIs. But the resource-based URIs is a good practice, right? It's a very important part of being RESTful. Next, let's look at HTTP methods. Now that you have decided what the address is, how do you interact with it? HTTP has what are called methods or verbs that you can use to interact with URLs. You must be familiar with the get and the post. They are very common verbs. A get method lets you get information from the server, and a post method is usually used when you want to submit information to the server. They work well with resource-based URIs that we've already seen. So a get request to the URI weather app / zip code / 12345 will get you the weather at that location. There's another method called put that you wouldn't normally use in standard HTML forms, but they're used very often in RESTful APIs. Put also lets you submit data to the server, but it's a little bit different from post, and we'll learn about this a bit later. There's also a delete method that lets you specify that you want to remove something, right? You want to remove a resource. So a good RESTful web service API makes good use of all these HTTP methods, right? As you can see, each method does something. It's meant to do something. So a good RESTful API design makes the right choices for the right methods. So not all requests are done using a post like a SOAP web service would do. A method that the developer chooses for each API depends on the action that's performed and the intended use. Now let's look at metadata. Okay, so we tell the client what the address is, right, and what HTTP method to use to call that address. Now when they make a call, what's the response that they get? A GET request for a weather URI. Obviously have the weather information. But HTTP also defines something called status codes. It defines something called response headers, which let the server send back extra information or metadata that might be useful to the client, right? So when you make a weather request, right, for a zip code, not only do you get the weather back, you also get this extra metadata, right? HTTP defines those things and you can get that. So one useful piece of information that every response has is the status code. It's a number that shows up in the very first line of the HTTP response, okay? And it indicates if the response was successful or if there was an error. If HTTP response is successful, a status code 200 is returned. If there is an error on the server sends back the status code 500. If you're trying to access something and the server is not able to find it, the popular error code 404 is returned. Now why error codes? When you're accessing a website, you'll probably get some HTML that explains a problem in case something goes wrong. For example, you access something, it's not available, right? It's not found. So a 404 error happens and you get a page that contains a page not found message, right? It probably has links to the home page, which helps the user navigate back to the home page. So it's for human consumption again, so there'll be a proper error message for the user to read. But in the case of RESTful web services, you cannot send readable messages because the client is a piece of code, which is why sending the right status codes is very important. If you send one of these codes which are designed for a particular purpose, the client piece of code can actually read that status code and understand what actually happened, whether it was a success, whether it was a failure. If it was a failure, then why it was a failure, right? It gives some information about what's actually happening along with the response. Finally, let's look at the format of the messages. Let's say you submit some data to the server as a post request. There's no specification that strictly enforces what the format of the data should be. Like we've already seen, it could be XML, could be JSON, could be some other format. Now, how can the server even identify what kind of data is sent? Similarly, how does a client know what data format is returned by the server, right? They're both talking to each other. Remember, it's very important that they both understand what the other person is saying. So if any format will do, how do they know what that format is? Answer is a header value called content type. Like I mentioned, a header value contains metadata, right? There are some headers in every HTTP request and response. They contain metadata about the message that's exchanged. And one such metadata is the content type, which is the format of the message, what format the message is actually in. There are some standard predefined content type values like text/XML for XML content or application/JSON for JSON content. A message that's sent with the right content type is easily readable by the server and the client because they actually examine the header and they say, okay, hey, this is an XML content type, so I'm going to parse it as an XML, or this is a JSON content type, so I'm going to parse it as JSON. So what's interesting is that usually in the server API implementation, the same API could potentially return multiple content types, right? The same API could return an XML or it could return a JSON, and what format it actually picks to return a response depends on who the client is and what the client says they want, right? This is an interesting process called content negotiation, which is again a very powerful feature. We'll learn about it a bit later, but basically it's the client saying, hey, I process XML, I prefer XML. And then the server, which could return XML or JSON, looks at that and says, this is a client which wants XML, so I'm going to give you in an XML format, right? So there's this negotiation that happens, which is pretty cool. So let's summarize. This was a broad overview of some of the important points about RESTful web services and how they're influenced by HTTP. So when you design a RESTful API, one, you need to have resource-based URIs. Every resource or entity can be identifiable by a single URI, right? You need to have that resource-based URI identified in your API. Two, you need to choose the right HTTP methods for different actions and operations for the API. It depends on what the API does. Depending on the operation, you need to choose the right HTTP method. Three, the response needs to return the right HTTP status codes. It needs to tell the client whether it was a success, it was a failure, what was the reason for the failure. There are some predefined codes. It needs to pick the right one when you are sending the response. And four, all request and response need to have the right headers. We gave the content type as an example, which is something which lets the client and the server know what the format of the message is, right? You need to set the right headers. In the next tutorial, we'll put these concepts into practice by implementing a RESTful API of our own. There are going to be tutorials about API design. We'll understand the principles behind good API design and why we need to do it like that. Also, following this tutorial is a set of exercises which test your knowledge of what we have covered so far. So give it a shot, and I'll see you in the next tutorial. Thanks for watching.